I'll do one more special video on factoring quadratics, and really I want to talk about ones with big numbers, with big lists of factors. Alright, here's an innocent looking trinomial. 4x squared minus 7x minus 30. No greatest common factors because 7 doesn't go into either of the other things. We're going to start listing A and B and C. And A is 4, B is negative 7, C is negative 30. So the reason I want to do this example is we have a nice big number here, 120. We have a long list of factors to do. That's ugly. Let's make that prettier. It's going to be up there a long time. All right, so we have a big long list of factors to do. And I know it's 1 times 120, and maybe you know a lot more of them. But I want to show you a tip why sometimes you might like to do a prime factorization, meaning we can do a factor tree like you would if you were simplifying radicals. That's your usual use for doing a factor tree. And so I'm just breaking this down into its prime factors. Those are both primes, so I'm done. This is 2 and 6. 6 is 2 and 3. Those are all primes, so I'm done. And I'm going to write these out. Oops, we're not doing a square root. I'm just going to write these out in order least to greatest. I could put exponents on them, but for our purposes here, better not to have the exponent. Let me double check. 2, 2, 2. Yep. 3. Yep. 5. Yep. And 6 was broken down into 2 and 3. So that's my prime factorization of 120. So as I'm doing my T-chart, and again, I said you have to do the list of factor pairs. If you want to do a prime factorization and not put them into the factor T-chart, that would be okay too. But I want to be able to talk through all these tips with you, right? I know that if I divide this in half and double this, that works. So I know 3 goes into it because 1 plus 2 plus 0 is 3, and if 3 goes into when we added up those digits, then 3 goes into the number. And I bet you know that it's 3 times 40, but let's see how we could get that 40. How could we have gotten this 40? Well, using our prime factorization, I could have said 3 times what gives me 120? Well, 8, 2 times 2 times 2 is 8, times 5 is 40. So 3 times whatever's left besides the 3 gives me the 120. That would have been another way to get that 40. All right, how do I know 4 goes into it? We have lots of ways to know that 4 goes into it. I could double this and cut this in half. Obviously, you know it was 30 because it was 4 times negative 30 that got us here. I forgot my negative. It's 4 times negative 30 that got us here. But again, let's look at how we could have used our prime factorization. 4 times 2 times 3 is 6. Times 5 is 30. That would have been another way to get your 30. Okay, does 5 go into it? Yes, 5 goes into it. If I don't have the prime factorization, I know 5 goes into it because I have all these terms here that end in zeros, so I know 5 must go into it, but that's maybe a harder one for you to see. So 5 times what is 120? I know it's 24, so I want to write that because it makes it easier the way I'm doing my video here. But where did I get the 24? Well, if I have my prime factorization, it's 5 times whatever's left. And this is 8 times 3. So 5 times 8 times 3 is 24. That's one way to get it. Another way to get it, even if you don't have the prime factorization, maybe you don't want to go through all that work, but you do have this entry above. You knew really easily it was 4 times 30. Just break the 30 down. It's 4 times 5 times 6, so it's 5 times 24. That's another way to look at it. Aren't numbers lovely? And that way, look, when I do 6, I know it's 6 times 20. Well, you probably know lots of easy ways why it's 6 times 20, but I have 6 times 20. That's another way to get it. Also, we could have doubled this, cut this in half, lots of other things we could have done. Okay. And then last, oh, not last, we have one. I was going to say 10 times 12 is last, and that one you guys know. I almost forgot 8. How did I know 8 went into it? Again, 8 times whatever's left. So it's going to be 15. Or you could have looked up and said, well, I know 8 goes into 24. 5 times 3 times 8. So it's 8 times 15. So you don't have to write out the prime factorization, but I want you to see where when sometimes with the big numbers, it'll help you not miss some of those factor pairs. Really good way to practice your math skills and learn how to build up numbers in alternate ways. So, okay, we're going to finish factoring this one. Which one of those pairs are we going to use to start filling in our boxes? I'm going to fill these guys in just because I want to get moving here, but which one of these is it's going to be? Well, I have quite a mess going on here, so let's change colors. We're looking for negative 120, and that adds up to negative 7. So I need to get a negative 120, one set of numbers, either the left column or right column has to be negative. And I know if this is going to be negative, it has to be the bigger numbers. And so it's going to be that one, right? 8 minus 15, 8 plus negative 15 is negative 7. So that's the one we're going to use. So I've got here positive 8x and negative 15x. So start factoring. These guys have in common just an x. These guys have in common a 2, and we take that sign, making sure I'm not missing anything there. 2, 4, 8, yep, just 2. These guys have in common a 4x, and these guys have in common a negative 15. Remember, this is where we're getting the signs. So my answer, x plus 2 times 4x minus 15. And I'm just going to quickly check my answer. 4x squared, I'm using FOIL for this because I don't want to draw the box in. 4x squared minus 15x plus 8x, that gives me negative 7x minus 30. So yeah, that works out. So I wanted to go through all those different tips on chopping up a big product into lots of little factors.